Hello everyone, welcome to PCB classes. Welcome back to the DC Machines lecture number 3. In the previous lecture, we have discussed about right hand rule, left hand rule, thumb rule, screw rule in order to know the direction of the induced current or EMF or to know the direction of the magnetic field. Now, moving to the next slide, let us see what are the subtopics we have covered till now. Now, the topics covered in the previous lectures are given as follows. The first one we have covered about the Faraday's electromagnetic induction law, type of magnets and its advantages. Then after we have covered about the Fleming's right hand rule, left hand rule, right hand thumb rule, right hand screw rule, notations of the current in a conductor, that is if it is entering then it will be in, if it is coming out or leaving it will be out, and the notations are given as in the previous lecture, and how to create and know the north and south pole of an electromagnet. That is generally depends on the sensing of the coil. What is that sensing of the coil means? In which way we are winding the electromagnet or the magnetic core. That is, if you are putting in the anti-clockwise direction, then the current will be moving in the anti-clockwise direction. If I am putting the coil in the clockwise direction, then the current will be moving in the clockwise direction. Depending on the current direction, the magnetic field direction will be also changing, due to which an electromagnet north pole and south pole can be also changed by using the technique of this sensing of the coil. Moving to the next slide. Now, as we know, the Faraday's electromagnetic induction principle has been classified into two laws depending on the type of induced EMF. One is the statically induced EMF, another is the dynamically induced EMF. So, as per that, we will be dealing with three things, that is, one is generator, second one is a motor, and third one is a transformer. Now, what is a generator? Generator is an electrical machine which converts mechanical energy to the electrical energy. Now, what is motor? It is an electrical machine which converts the electrical energy to the mechanical energy. Now, see here, both generator and motor starts with the word it is an electrical machine. Now, let us move to the transformer. What is a transformer? Now, transformer is an static electromagnetic device. I repeat, it is a device which transfers electrical energy from one circuit to the another without changing frequency. Now, what is my conclusion actually? Now, this generator and motor are said to be the electrical machine because they are associated with the electrical energy and they are converting the energy from one form to the another. That means electrical energy to the mechanical or mechanical to the electrical. So there is an electromechanical conversion in generator and the motor. So these are said to be the electrical machines. These are said to be the machines because the energy conversion is taking place here. Now, when I am talking about transformer cannot be said as electrical machine because it neither converts a mechanical to electrical or electrical to mechanical. Rather, it transfers the electrical energy from one circuit to the another circuit. So it cannot be said as an electrical machine. Rather, it will be said as an static electromagnetic device. That is why we will be saying this one as a device, not an machine. So in generally the standard books where you will be seeing the electrical machine means it will be written for the generator and the motor, but for a transformer it will not write as electrical machine. Rather, they will be defining it as a simple transformer only. As said earlier, first we will deal with the DC generator, then we will study about the DC motor. So let's start with the DC generator. First we will see the construction of the DC generator. There are various components of DC generator. First one is the magnetic yoke or the magnetic frame. which is the outermost part of the DC generator. Second one is the pole core and the pole source, which are basically electromagnets, which produces a magnetic field. Next one is a field windings. These are the windings which are present over the pole core in order to make them electromagnet. Next one is the armature core. Next one is the armature winding. This armature core and armature windings are said to be the core of the DC generator, or we can say it is the heart of the DC generator, because it carries the conductors which cuts the magnetic field, due to which rate of flux is linked in the conductor and an EMF is induced in the conductor. Next one is a commutator, which is basically said to be the mechanical rectifier which converts AC to DC. We'll see this commutator part in the upcoming slides. Next one is a brush, which collects the power generated and it fed to the load connected to the DC generator. Next one is a shaft. With the help of the shaft, we are giving the mechanical input to the DC generator, by which it converts the mechanical energy to the electrical energy. Moving to the next slide. Now here we will see the internal diagram of the DC generator. Now in the screen you can see the internal diagram of the DC generator, where everything is labeled, what are the components which we have dealt in the previous slide. Now here you can see the first one is the outer part, that is a magnetic frame or the yoke. Outer part is said to be the magnetic frame or the yoke, to which the electromagnets are connected, which are said to the poles. These are said to the poles. How many poles are there? 1, 2, 3, 4. 4 poles are there, and they have wounded with a windings, and it is connected to a supply, a constant supply. That is, these windings are said to the field winding, as already have said it. Now these are the poles, and over the winding which is said to the field winding. In the internal part, here you can see that armature is there, and armature are having some slots. We will go in details one by one in the upcoming slides, but for the time being I can say you that armature is made up of some slots, and within that slots we are placing the conductors. You can see the black dots which are the conductors in it, and it is connected to a commutator which collects the alternating current and converts into the direct current or the unidirectional current, and it has been given to the load with the help of the brush. This part is said to the brush. These are made up of carbon, and this part will be connected to the external load, to which the electrical supply will be given. Moving to the next. Here this is the cross-sectional view of the DC generator. A neat and labeled cross-sectional view is given. You can note it down for your exams. The same thing which we have seen in the previous slide, the same thing, but it is written, it is drawn very neatly, and it's labeled properly also. Let's move to the components of DC machine in details. Moving to the first one, that is a magnetic frame or the yoke. What is basically the yoke? Yoke is basically the outer frame of the DC generator or motor, to which the pole core and pole shoes are fixed. In larger DC generators or motors, it is made up of cast steel, whereas in smaller DC generators or the motors, it is made up of cast iron. Depending on the application, its constituent of the magnetic yoke or the magnetic frame differs. Next one, we'll see what is the yoke. Here you can see I have drawn the yoke here. Yoke is basically the outer part of the DC machine. Outer part. This is the part yoke. Now what it holds, already have said it, it holds the pole core and pole shoes. So when the pole core is connected, that is one of the maybe the north pole, another will be the south pole. It holds the pole core and the pole shoes. It's basically it gives a mechanical strength to the electrical machine. So let us see the functions of it. Now when we'll go for the functions, what are the functions here? It supports a pole core and pole shoes, thus provides mechanical strength to the machine. What is the next one? It provides a low reluctance path for the magnetic flux produced by the field winding. That means it produces a low reluctance path. What do you mean by low reluctance path? Reluctance is analogous to the resistance of the electrical circuit. That means in electrical circuit, resistance is a property of the material which opposes the flow of current, whereas reluctance is a magnetic property which opposes the flow of flux. So if it is low reluctance, that means more flux can pass through it. So it is a property of the magnetic material. Now you can see here the north pole and the south pole is there. As I already have said, from north pole to the south pole the flux will be traveling. Now you can see here from north pole to the south pole the flux is traveling. But what is the function of the yoke here? Here if north pole will be supplying flux to the south pole, north pole is supplying and south pole is receiving. That's it. That means it may happen sometimes that the north pole will be finished with the flux. It cannot give the flux or it cannot supply the flux. So how it can be? No, it doesn't happens like that. The yoke here which provides the pathway of this flux, that is this flux will be traveling from south to the north through the yoke. That means this yoke material should be very low reluctance so that it can allow this flux from south pole to the north pole. You can see in the slide from north pole to south pole the flux is traveling, whereas from south pole to the north pole it is traveling through the yoke, which is providing the low reluctance path to the flux. Thank you everyone. This is all about the lecture number 3. The rest of the components of the DC generator we will be discussing in the next lecture. Thank you.